Hey guys, it's Tim, bringing you a KTaNE tutorial today, talking about the module variety.
In reality, all he's doing is pushing the same buttons he always has. Nothing has changed.
Right. So this is the module variety, and as you can see, every instance of it looks different. The items are in a different location, and there's a different set of items that can show up. Similarly, the SVG in the manual actually works that way too. Every time you refresh the page, the SVG is randomly generated, not pulled from a list, but actually randomly generated every time you refresh. Just like the module. So you have a variety of different items that can show up, and this list over here is the kinds of things that can show up. So we'll find a nice one to start with. This one seems good. So first what we're going to need is some edge work. Two, three. 3 and 2. No indicators. Plate. DVI, RJ, RCA. Plate, RJ, RCA. Plate parallel serial, you saw that down there. And 8, 1, 5, Whiskey, Golf 2. So for some of the items you will need edge work. So I'll start down here. I'm gonna show you all of the possible items that can show up. Only 10 of them will show up on any given variety instance. And there's almost always 2 wires. In fact, there might always be 2 wires. Nope, this one doesn't have 2 wires. But there's usually 2 wires. Most of it, yeah, there's another one that doesn't have 2 wires. But anyway, a lot of the time there's 2 wires. But the color matters. So make sure you communicate all that stuff to your expert as the diffuser. So the first thing is the number 808-891-262-329. So we'll take that number straight on over to text field calculator. We're actually going to do this iteration twice for every item on the module, and there are 10 items. So take the number modulo n and then divide the number by n. So we're going to need the value, that's the result of the first step, and we're going to need the number generated by the second step for the next time that we do this iteration calculation. So first communicate to your expert all the things that are on the module. The order doesn't matter for how you communicate them. Their arrangement on the module is irrelevant, but the order will matter in a second here, and I'll show you why. So first we have a knob that has 1, 2, 3, 4, 5, 6, 7, 8, 9 ticks. So we have knob with 9 ticks. We have a yellow keypad. We have a slider with 3 ticks. One of the ticks is under the slider, so we'll call it 3 ticks. Slider with 3 ticks. We have a red switch. We have a red keypad. We have a white wire. We have a red wire. We have an LED. The initial states are black and blue. It's flashing black and blue. You don't have to communicate that to your expert right away if you don't want to. They can always ask later. We have a Braille. And we have a key, also known as key and lock. So that's our 10 items. going to start out modulo that by 10. And then we're going to divide it by 10. And so we get modulo 10 is 9. Divide by 10 is this number. And so 9 tells us which item to interact with, numbered from 0. Well, but first we have to get this list in order. So let's look at this list over here. And we'll put them in the right order. We have, and you also need to communicate to your expert that it is a vertical slider, because that actually makes a difference. Vertical sliders, top of the list. Knob with 9 ticks. There's the knob. It's under the red switch. So we can move the red switch above the knob. Braille, you can see, is above that in the list. You have Braille here. So we've got vertical slider, yellow keypad, Braille, red switch, knob, red keypad, key, red wire, then key, red wire, then key. Oops, our red keypad is above the red wire. Let's keep that in order. White wire, and then LED. Good. Slider, yellow keypad, Braille, red switch, knob, red keypad, red wire, key, white wire, LED. So this is the correct order of the items because of that list. And so the first one, the result of the calculation was 9. Therefore, item number 9, if the first one is 0, then the last one is 9. We're going to remove it from the list, put it down here, where we'll put our answers. So let's take a look at the LED section. Flashing between 2 colors. It was black and blue. Here's black. Here's blue. Here's the intersection. There are 4 items in the list. Here it says N is the size of the list. So N is 4. We're going to take our new number, mod 4. Answer is 0. And the next number is this. And if you want to, you can actually prepare the next one before we actually solve LED. So there are 9 things in the list. So mod 9 equals 1, and the next number is this. But we can ignore both of those for now because we're still solving LED. The answer was 0. Tap the LED once to switch into input mode. This list has 4 items. The result was 0. Therefore, we're going to do the first one, black. So we're going to tap the LED. It's going to change into input mode, and we're going to wait for the black color to show up, and then we're going to tap it again. Red, yellow, blue, white, black. There we go. I tapped it on black. And so that's finished. We won't actually know if it's correct until we touch something else on the module, though, because the module only strikes if an item is interacted with while an item earlier in the sequence is in an invalid state. So we won't actually know if this was right until we touch something else. And so it's very important as the diffuser that you not touch anything until it's actually time to interact with that part of the module. So don't be playing with the sliders or the knobs or the switches, which is actually a shame because you actually can't tell. There's some information you can't tell about the items unless you touch them, like letter displays and switches, but you actually can't interact with them yet until it's time. So we'll leave LED in that black state. The answer was black. So we'll do the next thing. We did this calculation already. The answer was 1. So we'll do take this list, item number 1, this is 0, and this is 1. So next we'll do the yellow keypad. So colored keypads, that's different than white keypads. The yellow keypad is right here. N is equal to B, choose K. B is the number of buttons. There are 4. K is obtained from the table. So 4, choose 3. Well, that's an easy one. There are exactly 4 ways to choose 3 items out of 4 possible items. And so what we need to do is write down the list of possible ways to do that, to choose 3 items out of 4. We're going to write down all the ways using 0s and 1s. And we're going to put the list in order of increasing numerical value if this was a binary number. So the first one would be 0, 1, 1, 1. The next one would be 1, 0, 1, 1. And so you'll notice in this case it's pretty easy. The 0 just scoots along. 1, 1, 0, 0. And 1, 1, 1, 0. That number is in order of increasing numerical value if these were 4-digit binary numbers. And that's actually a mistake. This is, there we go. 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 0, 1, and 1, 1, 1, 0. Those are the 4 possible ways to choose 3 items out of 4 items. You don't actually have to build the whole list, which comes in very handy when this list gets very large. The B choose K operation involves factorials, and so you actually can the list can get pretty big, you know. So you don't actually have to write down the whole list. You only have to write down as many as you need to find the answer. So the answer is the result of the iteration. Since there are 4 possible ways, n is 4. So we're going to take this number, we're going to mod 4, and we get 1. So we only really needed to list out 2 different things, the first 2, and then we could have stopped because this one is the answer. So we'll write down here that the answer is 1, and the next number is this. And because this is the answer, we can just write that down, and we don't need this. So what this means is, in reading order, the buttons we need to press are 1, 3, and 4, or in variety, 0-based indexing, buttons 0, 2, and 3. So buttons 0, not 1, 2, and 3. So we'll see if that's correct later when we interact with the next item. And because we did not get a strike just now, that means that our LED was correct. It would have struck now if it was wrong because we just interacted with the next item. There are now 8 things in the list. Modulo 8 is 3, and the next number is this. So 0, 1, 2, 3. That's what the 3 means. It means we're doing knob next. So knob n is the number of tick marks. We already know that it's 9. So we do mod 9. And we get 1, and the next number is this. And if you'd like, you can go ahead and do the next step. There are 7 items. There are going to be 7 items remaining. That gives you 5. The next number is this. But we don't have to do those yet. This is what we're focusing on, the knob. Find out which tick mark is state 0. Start with the up-facing tick mark up here. Move counter. Move clockwise a number of tick marks equal to the numeric value of the first character in the serial number. So first character in the serial number is 8, which is already a number. Otherwise, you would convert it into a number using that rule there. So it's 8, and that means that the 0 tick mark is 8 clockwise movements away from the upward one. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is tick mark 0. Obviously, you could have just gone one left because there's 9 of them. So this one's tick mark 0, and the answer was 1. So 0, 1. We need to set the knob right there. 0, 1. And we now know that our keypad was correct because we didn't strike when we touched the knob. And so we'll find out if this is correct in a minute. And so the next one is item number 5 in this list of 7. So this is 6, this one's 5. Next up is key. So for the key, N is 10. Always. This is very much like turn the key, the module turn the key. You just have to turn it at a particular time. It's only dependent on the last digit of the timer, not the whole timer. So mod 10 gives you 3, and the next number is this. And just as it says here, turn when the last second's digit is equal to that value. So the answer to key was 3. I'm sorry, I should have been writing these down. The answer to the knob was 1, which is the top. That is, if you wanted to do this as an expert, work out the answers and then communicate it back to your diffuser, because doing this interactively would take a really long time because there's calculations in between each stage. But you certainly could do it interactively. Just say, all right, go press these buttons on variety, and then then you can go do other things while I work on the next calculation. That's fine too. So key, turn it on 3, 3, 2, 1, 0, 9, 8, 7, 6, 5, 4, 3. There we go. I turned it on 3. So, and we'll find out if that was right the next time. So I'll do the next thing here. There are now 6 items left. And as you can see, it's starting to get pretty familiar. Mod 6 equals 4. The next number is this. So since it's 4, 0, 1, 2, 3, 4, we're going to do the red wire next. So we'll go to the wires section. Red wire. Red wire. More parallel plus serial ports than any other ports. So let's see, we have a parallel and a serial, and we have 1, 2, 3, 4, 5 other ports. So that is false. More parallel plus serial ports than all other ports. If the condition in this table is false, 1 means cut and 0 means don't. Otherwise, reverse it if the condition is true, but it's false. So 1 means cut. And our result, n is 2, because it says n is 2. There's only 2 things you can do with a wire, cut or don't cut. That's generally how this works. N is the possible states that you can set something to. So n is 2. The answer is 1. And the next number is that. And so since this is false, 1 means cut. So we're going to cut the red wire. And so the next thing we do, there are 5 items left. The result is 2. 0, 1, 2. We're going to do the red switch next. N is the number of positions that the switch can be toggled. So this is one of those things that you couldn't communicate with your expert at the beginning of the read, because you're not actually allowed to touch the switch until now when it's time to interact with the switch. So we'll find out. 1, 2. It has exactly 2 positions. So our n is 2. the result of which is 1, obviously, and the next number is going to be that. So the result is 1. And for this one, you just put it in position 1. So this is position 0, and that's position 1. Sometimes the switch has more than 2 positions, and so you put it in the position corresponding to the right index. So that was 0, and this is 1, so we're going to leave it down. Position 1, we'll write that down to tell our diffuser, but since we are the diffuser, we'll just do it. And so the next thing, we have 4 items left. Mod 4 gives 0, divide by 4 gives this. So 0 means we do the first item in the list. We're going to do the vertical slider with 3 ticks. Here we go, slider, n is the number of tick marks. There are 3 ticks. So mod 3 is 1, divide by 3 is that. So states are numbered from 0, starting on the left for horizontal and the top for vertical. So since the answer is 1, we're going to make the slider go to position 1. So that's position 1 right there. This is 0, and that's 1. That's it. Now we know that the red switch is in the correct position because we just touched the slider and we didn't get a strike. So we'll do the next thing. 77. There are 3 modules left. There are 3 items left. The answer is 2, and the next one is 25. So 2 means 0, 1, 2. We do the white wire next. That's an easy one. We already know how to do wires. N is always 2. The answer is 1. The next one's 12. So we'll go ahead and go over here to wires. It is a white wire. Are there more D batteries than AA batteries? Well, there's 3 and 2, so no, because there's 1 D and there's 2 AA. So is there more D than AA? No. So condition is again false. 1 means cut and 0 means don't. And 1 was the answer. So that's a cut. There we go. Okay, there are 2 items left. Mod 2 gives you 0, and the next one is 6. So 0 means that we do the first one in the list. That's Braille. N is the number of distinct characters in the serial number. So 8, 1, 5, W, G, 2. There are no repeating characters. So that's 6. 6 mod 6 is 0. 6 divided by 6 is 1. So our result here is 0. The value identifies which of those characters to input in Braille. So we're gonna that would be character 0. Character 0 is an 8. Digits are input as letters, except shifted down 1 row. So 8 would be H, hotel. We'll go to Braille. And so this is the pattern, because 8 gives you H, but shifted down 1 row. So we're going to put the dots in 2, 3, and 6. The answer is 2, 3, and 6. That's what you would tell your diffuser. So we'll just do that. 2, 3, and 6. And so what's next? There's 1 thing left. We mod 1, and we get 0. We divide by 1, and we get 1. So since the result was 0, obviously we do the last thing in the list, which is also the first thing in the list, red keypad. So we'll go back to keypads. N is once again B choose K. Red is 2. Right. There are six things, and we need to choose 2 things. So what is 6 choose 2? 15. So 1 mod 15 is 1. And since we're on the last item, we don't actually need to do the division. If we did, the answer would be 0, though, obviously 1 divided by 15. And so good, the answer is 1. We only need to list out a few different options. We know how to do this. There are 6 things. So the first one, choosing 2 things, would be 0, 0, 0, 0, 1, 1. Numerically, that would be first. The next thing in the list would be 0, 0, 0, 1, 0, 1. So we're still choosing 2 things out of the list, and this is the... So now we've officially tried all possibilities that start with 4 zeros. So the smallest number that starts with 3 zeros and then has 2 more 1s and a 0 somewhere in it would be this number, 0, 0, 0, 1, 0, 1. It's a pretty easy pattern. Once you've done this a few times, if 0, 0, 0, 1, 1, 0 would be the next one. And now we've run out of ways to start with 3 zeros. So 0, 0. And again, we don't need to do this. We know that this one is the answer. It's the second one in the list because 1 was our answer, but I'm just showing you how this works. So now we have to start with only 2 zeros, 0, 0, 1, 0, 0, 1. And the next one will be 0, 0, 1, 0, 1, 0, and 0, 0, 1, 1, 0, 0. And so on and so on. But a good expert would just stop right here because he would have done the math first, found out that the answer is 1. So this is our answer. We're going to choose buttons 0, 1, 2, 3, and 5. Or if you would prefer, buttons 4 and 6. So, and that is in reading order. So 1, 2, 3, 4, and 6. And there we go. Module is solved. So I'll show you a few of the other things. This thing has letter display, white keypad, maze, and digit. Look at that. Start with our number. I'll just get us started on this, and I'll let you know. I'll skip to when we get to one of those things. That number, mod 10, is 1. There's the next number. So let's write down all the things that we have here. As you can see from this list, it matters what size of maze we have. And for the white keypads, it matters what the dimensions are. So make sure you tell your expert those things. We have a digit display. We have a 3x3 maze. We have a 1x3 white keypad. As you can see here, 1x3 is the tall one, and 3x1 is the wide one. So this is a 1x3 white keypad. We have an LED flashing red and white. We have a yellow switch. We have a key. We have a letter display. That's this green one. We have a black wire. We have a red wire. We have a white switch. Okay, got my list in order now. And as luck would have it, this number, mod 10, gives you 1. And so we're going to do the 3x3 maze first. So let's do that. We haven't seen that yet. Go over to the mazes. Look at the 3x3 maze section. Something that you could have communicated to your expert during the read is that the 3x3 maze has a yellow cross. So it has a plus that is yellow, so this is our maze. And the cells of the maze are highlightable, so that's nice. You could have also told them, if you really wanted to, that we're starting in Bravo 3. But that doesn't really matter, because they'll just tell you how to navigate the maze when it's time, and they could have asked you then where the thing is. So n is the number of positions in the maze. So that's 9. This is a 3x3, so there are 9 positions in the maze, obviously. So mod 9 gives you 6, and the next number is that. So the value is the goal position, top left being 0. The answer is 6, 0, 1, 2, 3, 4, 5, 6. So that's our goal position. The plus is here, so all they have to do is go left. Yeah, tell them the position is 6. And then they'll tell you where it is, and then you'll tell them go left. There we go. That's now in the correct position, and we didn't strike because we didn't hit a wall, but we'll know if we're in the right position when we touch something else. So we'll do mod 9 on this. And again, we get 6. That's the next number. So 0, 1, 2, 3, 4, 5, 6. The next thing is white switch. The expert is going to need to know the positions of that, so I'll just touch the white switch. There we go. So you'll notice when I did that, the digit over here changed from 2 to 1. That's something I forgot to mention, is that the digit, it works like forget it not. Not forget me not, but forget it not, where you have to write down what the digits were during each interaction phase, during each item interaction. So while we were interacting with maze, this thing lit up and it was a 2. And so you write down 2 on the left side here of your notes. And then when we interacted with the switch, the digit changed to 1, so we'll put a 1 next to the white switch item. It works like forget it not. You're going to need to know those numbers later on when it's time to deal with the digit. So we interacted with the white switch and didn't get a strike, so this maze is solved. So I've just touched the yellow switch, and the digit changed to a 4, so tell your expert that the digit at the yellow switch stage is 4. Oh, and by the way, wires don't count for the digit, as you can see here. Set the display to the digit it showed in blue when the item was interacted with. N is the prior number of items in the process excluding wires. So you don't get a stage number when interacting with wires, and that's because sometimes you don't need to cut the wire, and in this case, we didn't need to cut the wire. So when I touched the yellow switch, we knew that that was correct, and we got a new number for the switch, which was 4. I just submitted LED, and number changed to a 6, so we write down 6 for that stage. This number mod 4 is equal to 2. Next number is that. 0, 1, 2. Okay, it's time for the digit. So, digit, N is the number of prior items in the process, excluding wires. So we had 2 interactions with wires, or rather 2 non-interactions with wires. They were both don't cut. So we got 4 stages out of the digit as we were interacting with the 4 prior items that were not wires. So N is 4. I skipped over the boring stuff that you have already seen. So now we're at this stage. Mod 4 gives you 3. Next number is 204. So Set the display to the digit it showed in blue when that item was interacted with. So item number 3 in this list of 4 items would be the last one. So that would be this one. When we were interacting with the LED, we got a 6, and therefore the answer is 6. So we'll change it to 5 and then back to 6 because we need to submit it in yellow. It changes to yellow when you touch it. So we'll just leave it at 6 and we'll know if that's correct in a minute here when we do the next thing. There are 3 items left. So we're going to do the first one, the white keypad. Good. So white keypad is interesting because it has its own iterative process, and it's different than the other colored keypads. So what we're going to do is make a list of the possible buttons that you can push, button number 0, button number 1, and button number 2. Or if you would prefer, you could do buttons 1, 2, and 3, but if you look in the log, it's going to do it as 0, 1, and 2. Everything is 0 based in this module, so we'll do buttons 0, 1, and 2. Obtain the order in which to press the keys by applying the iterative process to the obtained value. So the obtained value, n, is the factorial of the number of keys. So 3 factorial would be 3 times 2 times 1, so that's 6. 68 mod 6 is 2. And the next number is 11. But we're going to need this 2 here because we're going to apply the iterative process to the obtained value. The obtained value is 2 in this case. So we're going to start with 2 as our number, and we're going to apply the iterative process where in each iteration the value of n for the nested process is the number of remaining keys. So this particular thing is a little difficult to understand. Let me explain what it means. First, you make a list of the number of buttons like we already did, 0, 1, 2, and then we're going to apply the iterative process where this is our list instead of this list of items. We're going to make this our list for this item here. We're going to start with 2, which means button 0, 1, 2. So what that means is you choose item number 2 in the list of button indices. So item number 2 would be 0, 1, 2. The first button we're going to press is button number 2. And then we delete 2 from the list, and we go again. There are now 2 things left in the list. 2 mod 2 is 0. 2 divided by 2 is 1. So since this is 0, the next one we're going to press is item number 0 in the remaining list. This is the remaining list. Item number 0 in this list is 0. Okay, we'll get rid of 0. 1 mod 1 is 0. And 1 divided by 1 is 1. But we're already out of items, so we'll just choose item 0 in the remaining list. This is the remaining list. Item number 0 is 1. So the answer is press buttons 2, 0, 1. So this is 0, 1, and 2. So we'll do 2, 0, 1. Okay. And that's how keypad works. You have to keep a list of the remaining buttons and keep applying the iterative process. I'll show you another one in a minute after we've done letter keys here. Mod 2 gives you 1, and the next thing is 5. So item number 1 would be the letter display. So the letter display is nice. It's just like password. Now we are able to interact with it. So you couldn't have given the expert this information when you first did the read because you weren't allowed to touch letter display until just now. So we're going to find out which characters are available in each slot. Uniform, Romeo, Charlie. And because we didn't strike when we started interacting with this, that means our white keypad was correct. And we'll do the next slot, Uniform, India, Echo. And the third slot, Papa, Sierra, Delta. Okay, and then we'll look in this list here and we'll find out what words we can make using those the number of letters in those slots. So first we'll look at the uniforms, and the second letter being Uniform, India, Echo. So there are no words that start with uniform. Okay, we'll move on to Romeo, the second letter being Uniform, India, Echo. Here's Romeo's. Well, here's the Echo section. The third letter is either P, S, or D. And there's a D. And we'll move on to RI. And again, P, S, or D. Here's D. And there's no P or S. And then we'll move on to uniform. And again, P, S, or D. There's no P, S, or D. So we'll move on to Charlie. Charlie words are over here. Uniform, India, Echo as the second one. There's no Indias, there's no Echoes. There is uniforms. And the third letter is P, S, or D. Here's the P. And that's all. So we can spell 3 things out of this list. Usually it's more than 3. Usually I would say 5, 6 things that you can spell. But sometimes it's a low number like this. So we can spell 3 things. Obviously 5 mod 3 is 2. And the remaining number would be 1 there. You can see these numbers get very small very fast. We're not even on the last item yet, and we already have 1 as the number now. So anyway, 5 mod 3 is 2. And so we find item number 2 in this list of 3 items that we can spell. And since they're numbered from 0, 0, 1, 2, it's the last one, of course. The answer you would tell your diffuser is RID. RID. And we won't know if that's correct or not until we interact with the next thing. That would be the key, but let's make sure you do the math. Don't forget to do the iterative process. You have to do it in order to get the correct numbers when you arrive at that item. So 1, there's 1 thing left. So 1 mod 1 is 0. 1 divided by 1 is 1. So we're going to do item number 0. And there's in a list of only 1 thing. That's obviously key. You guys know how to do key already. N is 10. 1 mod 10 is 1. 1 divided by 10 is 0. But that division is actually irrelevant because we're on the last item. But so 1 is the number we're going to use. Last digit being 1 is when we turn the key. 8, 7, 6, 5, 4, 3, 2, 1. There we go. Module solved. So that's how you do letter grid, maze, digit, and white keypad. The only thing left is button, but I'll go over white keypad again because just for me personally, it's a little confusing. So it'd be nice to see another example. Skip ahead until we get to the new items for you guys. We have another 3x3 maze with a blue star. We have Braille. We have a white 5-sided button. That is the way to read this. White 5-sided button. They're going to need to know that information. There's an LED flashing white and red. There's a key. There's a blue switch. And that's everything. So I'll just put the items in order. Oh, and by the way, the mazes do go all the way up to 4x4. So there's 3x3, 3x4, 4x3, which is the wide kind of the wide version of 3x4, and the 4x4. So make sure you know that. Just solve this maze for you guys. Okay, I've skipped ahead. And now we arrive at 2 items left. Mod 2 is 0, and therefore it is time for the white button, the white 5-sided button. So go up here. N is K plus P. K is the value obtained from the table. It's a white button. K is 3. P is the number of corners or sides. So 3 plus 5 is 8. So n is equal to 8. 2 divided by 2 is 1. 1 mod 8 is 1. 1 divided by 8 is 0. So, because the value is 1, we say, is the obtained value less than k? Is 1 less than k, which is 3? Yes, it is. Hold the button across that many timer ticks, okay? So otherwise, if the value hadn't been less than k, which actually this is the first time I've ever seen it less than k. Usually it's bigger than k. And then what you do is you subtract k minus 2 from the value. So let's say the value had been 5, which would have been greater than k. Then what you would do is subtract k minus 2. So 3 minus 2 is 1. So you subtract 1 from the value, and I made up the value 5 for this example. So you would have 5 minus k minus 2. K minus 2 is 1. So 5 minus 1 is 4. And you would tap the button 4 times. But our value is less than k. So we're going to hold the button across that many timer ticks. And our value is 1. So 1 timer tick. So I did that. I waited for the timer tick sound and I let go. That was 1 timer tick. And now it's time for the white keypad. So there is 1 module left. 0 mod 1 is 0. 0 divided by 1 is 0. So our value is 0 for the iterative process here in white keypad. So n is the factorial of the number of keys. 3 factorial, 3 times 2 is 6. So 0 mod 6 is 0. So we're going to start with the seed 0. And this one's actually quite boring. Or once you arrive at 0 in the iterative process, you're always just going to do the lists in order. Because you have... But let's just run through the steps, though. We start with 0. That was our result. So we take 0. First button we press is index 0 in the list of remaining keys. And so what's at index 0 is button 0. So first one we press is 0. And so 0 mod 2 is 0. 0 divided by 2 is 0. And so 0 mod 2 is 0. That means we're going to take item number 0 in this list. That would be a 1. And you can see where this is going. It's always going to be in order. Once you hit 0 in the iterative process, but we'll just do it anyway. 0 mod 1 is 0. 0 divided by 1 is 0. That last one doesn't matter because we're out of keys now. The last one is 0. Item number 0 in this list is 2. So we'll press 0, 1, 2. And that's a solve module. So it's pretty simple. Okay, let me just give you one more example here of the white keypad, that is, because the way I explained it wasn't very good. Let me walk you through one more example here. It just so happens to be the first item in the list, the first item in this particular one. So I've put the items in order already. Started out with this number. Mod 10 is 7, 0, 1, 2, 3, 4, 5, 6, 7. So we are starting off white keypad. So factorial of the number of keys, that's once again 6. This thing, mod 6, is 4. So we're going to start with 4 as our number, and we're going to begin to do the iterative process. We'll start with the list 0, 1, 1, 2, 3. 0, 1, 2. Key numbers 0, 1, and 2. So clearly we start with 4 as the number, not the value. Therefore, because obviously you couldn't choose item number 4 in this list, or because there's only 3 items, items 0, 1, and 2, there's no 3 and there's no 4. So clearly we can't start by pressing 4. This is our number. So I just wanted to make that really clear because I didn't really explain that very well earlier. We start with the number 4 and we modulo with the number of items. So we start off with the number as 4, we modulo with the number of items in this list here, and that would be 3. 4 mod 3 is 1, 4 divided by 3 is 1. So the first answer is 1. So we take item number 1 in this list, 0, 1, and we're going to press button 1 first. Now our list is 0, 2. So we'll apply the process again. 1 mod 2, because there are 2 items left in this list. 1 mod 2 is 1. 1 divided by 2 is 0. So the answer is 1 here. We take item number 1 in this list, and that would be 2. And so we're going to press 2 second. And when we apply the process again, there's 1 item left. 1 mod 1 is 0. So item 0, obviously 0. So the first thing we would do in this particular module is press the keys in this order. 1, 2, 0. And now we have a digit. But just so you get really clear how to do white keypad, because to me it is the most easy to screw up. And I kind of did screw it up as I was explaining them twice before in this tutorial. But now you know the correct process. Make sure you use this as your number, and not the first value when you're doing this iterative process. Because obviously sometimes it can end up actually bigger than your number of possible items. So clearly that can't be the value. It has to be the starting number. So that's the module variety. As you can see, it offers quite a variety of different things that you have to do each time you do it. It goes on a little long. You know, it's a very long process of solving 10 different things. Each one is pretty quick, but it is 10 different things that you have to solve. So that's the module variety. Thank you for listening, and I hope this helps.